But we're thrilled to be here, and thank you for the opportunity. We are out in California, where it was only about 28 degrees this morning, and that's already warmer than I think all of you are right now, at about 20 or in the teens maybe. And our high this week has been about 48, 50. So we're definitely warmer. It's California, but we're not significantly warmer. So what we'd love to be able to do is ask everybody what kind of vegetable farming they're doing, or farming in general. We always love to hear that from our audience of who we're talking to, but unfortunately we're just gonna have to give our wonderful presentation, I hope. And we'd love for everyone to take away whatever they can take away from it to apply to their own context. But we wanna definitely start with a lot of the science behind why we do what we do before we even get into how we do it. I think understanding the science, understanding the relationships allows for a much clearer picture of how to proceed in your own context, in your own capacity, in your own markets, etc. But first,
and adding on to that, we're going to go through the principles of soil management, as so many different farmers do, so that hopefully you'll see that this isn't specific to us in Northern California. Great. So here is an overhead of our farm, and just a little bit about us. We're in Sonoma County, which is about an hour and a half north of San Francisco. We are down in Little Valley Bottom. We have 8 acres of property, and our actual production is about 2.5 acres of size. So you're looking at about 80% of it in this photo. This photo was taken October 25th, a couple of years ago. So this is us completely stacked to go through winter. We have about 40% of our produce goes to our CSA. We do a year-round CSA, 40 harvests per year. So that's weekly from May 1st through Thanksgiving. And then from Thanksgiving through the end of April, right now, it's every other week, just because things are growing more slowly. And then about 50% of our produce goes out through farmers markets. So really a lot of, direct to consumer sales. The last little 10% is restaurants and a tiny bit of wholesale.
Just to give you an idea too, the foreground in the photograph, those long beds at the bottom of the screen are really only about 120-foot beds, and the last 10 feet is actually cut off. So it's a little distorting the perspective on this. Was that enough for intro? Yeah. So one of the things that we love just talking about, obviously, is soil. And soil is one of the big reasons that we're doing what we're doing. And I just love this quote, even though it's not necessarily relevant for where we are farming or where you are farming, it's important to understand the capacity for healthy soil. And so this quote about every time you take a step in a mature Oregon forest, your foot's being supported on the backs of 16,000 invertebrates held up by an average total of 120,000 legs. That's just a reminder of the macro as well as the associated microbiology that can be in healthy soil. And it is well understood that tillage is one of those major practices that has reduced the organic matter level in the soil over many decades and many centuries. As we know, human civilizations used to manage soil fertility through rotational practices. You farm an area for 3 to 5 years until you blow out the soil, you move over to another patch of land for 3 to 5 years, move over to the next patch for 3 to 5 years, and about 20 or 30 years later, you cycle back around that first 3 to 5 acres or so that you farmed. So we definitely did rotational cropping as a way to manage fertility. And in some parts of the world, people still have plenty of acreage where they can do rotational cropping, and that's a fabulous way to manage fertility. But in some areas, we are pressed to farm every acre we have every single year. And that is a heavy toll to take on soil fertility.
Yes, and in our area where our cost of living and the cost of real estate is so high, we definitely need to intensify and be small and continue to farm year round.
So just as an example of, well, first of all, so how does tillage impact soil organic matter? And first of all, about half of soil organic matter is carbon. About 57% actually is about carbon. And tillage, obviously, one of the things it does is it's breaking up soil aggregates into smaller and smaller sizes. And that it creates more surface area to volume ratio of soil aggregates, which helps to release more of the carbon and nitrogen in the soil, and it combines with the oxygen being mixed into the soil through the tillage equipment, and that carbon and nitrogen combine with the oxygen to form carbon dioxide and nitrous oxide, 2 of the most potent greenhouse gases. But generally speaking, that active tillage is removing carbon and nitrogen from your soil, which are 2 of the things that we as farmers need most in our soil. So that's one of the ways that tillage begins to degrade the organic matter in the soil. And on this screen, looking over the far right to the erosion, this is just one study that I've got dozens of studies like this, mostly from the USDA. And while this is an older study, it still was impressive to look at the amount of erosion happening in moldboard plow fields versus no-till fields. And these were down in Tennessee on equivalent sloped soils, type of soil and slope and crop. And what you have is 700 times more erosion on the moldboard plow fields than the no-till fields. And if you think about that, that means that you could farm the fields with no-till practices for 700 years and have the same amount of erosion as you'd have in 1 year of plowing with the moldboard plow in this circumstance. And that's actually another part of this aspect that I want to share of this chart is the 4,700 pounds of soil loss per acre per year average. In the 1970s and 80s when the study was done, that was about half the national average for erosion pounds per acre. The national average was 9,700 pounds of soil per acre per year. So even in this study, that moldboard plow field, or 4 fields, were doing far better than the national average. So it's important to understand how tillage impacts our soil organic matter. Another way is that it directly impacts the biology in the soil. And I first started off talking about that macro and microbiology in our soil. Well, this is a great quote from the USDA. Tilling the soil is the equivalent of an earthquake, hurricane, tornado, and forest fire occurring simultaneously to the world of soil organisms. Simply stated, tillage is bad for the soil. And that's a pretty obvious thing to say, I guess. I don't even need to go further into that one. And globally, we've already lost roughly 2/3 of our total soil carbon from our planet's cultivated arable agricultural soils. And most of that soil organic matter has been lost in the past 70 to 100 years when we have mechanized tillage. And we have definitely expanded our population across the planet, expanded the arable land, and expanded our efficiency through mechanized tillage, so that we've had a far greater negative impact on our soil health. Another stat to look at, to kind of sum it up differently through the USDA, is pre-cultivation topsoils in the US back in the 1800s and 1700s were seen to have 6 to 10% soil organic matter, SOM. And today they average between 0 and 3%. And in our bread basket of California, our fruit basket and vegetable basket, we have a whopping 1% organic matter. And that is down from the 1.1 and 1.2% it was just a handful of years ago. So we continue to degrade our own soils here as well. So looking at that, it's also intriguing to think about if you want to mitigate greenhouse gas emissions. Agriculture actually has the greatest capacity at the cheapest cost of euros per ton equivalent. And this is because obviously the act of tillage, which has been removing so much of our nitrogen and carbon from the soil, all we have to do is put it back in. It's a very cheap and efficient way to begin to remove excess gases from our atmosphere and put them back into the soil, where in fact they will help our soil and biology and overall productivity. And of that, 89% of that potential mitigation comes from better soil management. So a lot of people like to talk about, sheep farts and cow farts or methane from rice paddies, but really 89% of that potential is through better soil management. Now, just a quick side-by-side photo for Singing Frogs Farm. I think many of you may know that when we first began farming, we had about a 2.4% soil organic matter, and our carbon was about 1.4%. And we were doing tillage in the beginning. We actually didn't have any vision of no-till. We simply wanted to do the standard organic practices that seemed the best out there. And we began tilling, and the quality of the soil went from a sandy loam to concrete rather rapidly. It was a great challenge for us to farm using tillage in our soils. And we saw the organic matter get blown out very fast. Nutrients were depleted. Weeds became voracious, and we couldn't get rid of them because their roots were locked up in the concrete soil in the summertime when things dried out. And so we eventually switched over to a form of no-till, which today is all we do. And you can see the quality of the soil on the right is much more, we like to say, like chocolate cake. You can sink your hands into it. We've had soil scientists come out with 4-foot probes and lean on the probe, and it sinks right to the handle with very little pressure. And our soil organic matter is now between 8 and 11%. And we've tested and found not only has the organic matter content almost quadrupled, but so has the biology in our soils quadrupled at the same time. So I've lost capacity to do that. Somehow we can't look at questions asked and change slides at the same time.
Oh,
there we can. Okay. We figured it out. Thanks. So, go for it, hon.
Just a couple of technical difficulties. We're working through them, so thanks for bearing with us. And thank you also for bearing with us. We do like to go over that, although we recognize that most of you have a very good understanding of soil, just so you can understand our way of thinking about it and how we come to it. So, managing for soil health, we got these. You've seen these before from the NRCS, and we're going to go through them just to describe how we do these. First, disturb the soil as little as possible. Why do we want to do this? Because we don't want to disturb these critters in the soil. Paul just talked about this. This photograph is from some friends of ours, Shannon and Mike, who run Hillview Farm that's up in the Sierra foothills. And this is after just their first year of transitioning over to no-till. So you can see there's some very clay soil. There's definitely some compost. There's some fungus. There's, obviously some earthworms. And we're going to talk about, we're actually going to show you how we transition beds and talk a little bit about how we start up a field as well. Here's another photo. This is from our farm. This is a harvest of escarole in the early springtime. Obviously don't want to till this up, so you're looking at the stem right at the soil surface there. So not going to stay with that much longer. Moving on to keep living plants in the ground as often as possible. Why do we want to do this? I love this description by Christy Jones, talking about photosynthesis, taking that carbon out of the atmosphere, resynthesizing that first into glucose and then into a myriad of different carbon-based products. Exudation, then pushing that out to feed the microbiology in the soil and building up the humus. This is a slide I got from Ray Archuleta. I just love looking at this. Granted, this is in a petri dish, not in the soil. But just the roots exuding those carbon-based products and feeding the bacteria and the fungi that are then feeding the entire soil food web. Could sit and watch that for a while. But. So
conversely, what's important to me is thinking if there are no green living plants in soil, there is no food to feed your organisms.
Right.
So you have soil that's starving if there aren't any green plants in it.
So you have probably seen the soil food web slide. Got this again from the NRCS. How are we going to feed all of those organisms getting up to your birds and your animals is through that process of exudation as well as decomposition. And now this is a slide from our farm, and we did this autumn in October, really looking at how is our soil holding together. So as those roots are exudating, the microorganisms they're feeding are going to be creating the glomalin. So we wanted to see how our soil holds together. So in this slide, you've got a little picture in your upper left. That is our soil. It came out of a bed that had tomato plants in it for 6 months. And then we are bordered by a 140-acre conventional vineyard. And so the larger picture that you see here is from them. And that is what our soil looked like when we first moved here. We have a very sandy loam soil. You can see it just sloughing off. Sort of like erosion underneath water.
There's no glomalin, there's no soil biology, there's no critters, there's no glomalin holding the soil together. It's a great example and way to look at biology in your soil and its benefits. And so, yeah, there was just sort of torrential cascades of soil falling apart from the vineyard soil. And oh, look at that, it did do the video for the other one. And our soil in the upper left is now in live video, and it's not moving. This was simultaneous videos left and right, and there's no soil cascading off. The glomalins are holding that soil together beautifully, and yet the soil was super lightweight. When we put it in the water, it almost wanted to float. It had so much oxygen in the soil, despite having had tomato plants in it for 6 months. It was not concrete. It was actually this gorgeous chocolate cake. So this is a quick picture of 15 minutes later, the vineyard soil and how much had sloughed off, versus 24 hours later, how little had sloughed off our soil in that water test. This is 24 hours of sitting in water, and
you took
almost nothing had come off.
These aggregates from how far down?
These were between about 6 and, well, the vineyard soil was between 5 and 7 inches, and I couldn't go below that because that was the hard pan from the tillage. And so that was 5 to 7 inches. And I really actually hurt my wrist trying to get that soil out. And the soil from our tomato bed was down between, I wanted to get the equivalent. So it was about 6 to 8 inches, 6 to 10 inches. That's what I was taking. Down where we had the most roots and biology and activity.
Great. So talking about keeping green photosynthesizing plants in the ground as often as possible. And for us, that just means one crop and then the next crop and then the next crop. And we'll talk about multi-cropping in a minute, but we really aim to do 3 to 8 sequential economic crops in any bed per 12-month cycle. Granted, we have a slightly different climate out here, but you can also see in the left of the slide, we do have hoop houses. We have 5 on the property that definitely help with our season extension. And then grow as many different species of plants as practical. And so you can see here just lots of different plants, 2 rows of peppers, and then followed by, there's 4 rows of Brussels sprouts with a line of fennel down the middle. Lots of intercropping that we do. Here you've got 100% crop cover of a Romanesco cauliflower. Those are the big light green fractal shaped cauliflower. They need very large spacings. They're huge plants. And then we've got about a 60% cover of a Panisse a Panisse lettuce. And so that will harvest out just as the canopy of the cauliflower is starting to close. So we've got more photosynthesizing plants in the ground, and we've got more of a diversity. We're getting more crops out, which is feeding our community. And, it's holding moisture in the soil, feeding the biology, so on and so forth. Here's another example, leeks. When the day the leeks were planted, and then later, we really think about architecture when we're looking at what sorts of plants to grow together. So with the leek, we're choosing mini romaine lettuce that is upright versus the cauliflower. We're choosing something that's flat against the ground like that Panisse lettuce. Here with our tomatoes never go in without a light crop on the side. On the left, there's some escarole and frisée. On the right, there's some red butter lettuce. And if we get them in early enough, we'll even get 2 crops in there.
Nothing like having 2 lettuce crops in the bed while your tomatoes are growing. It means you have a constant economic revenue rather than plants sitting, taking up space, waiting to grow big enough to produce fruit. So, and that includes perennial hedgerows for crop diversity. And I cannot actually say enough about hedgerows, especially if I were in a place like Iowa where you tend to have more exposure and more wind and more elements. And while hedgerows obviously provide all kinds of habitat for beneficial insects and songbirds and pollinators, which do a great job of pest control and pollination services, honestly, the biggest reason that we love our hedgerows is for climatic stability. They really reduce wind speed, not only for the crops, but at the soil level as well. So we think about the benefits to the plants themselves, as well as all the biology in the top few inches of soil. The hedgerows just provide so much more protection to stabilize the climate and stabilize the atmosphere. And on those really hot summer days, it's a little bit cooler near the hedgerows. On really cold winter mornings, it's a little warmer near the hedgerows. We're seeing that right now with much better crop growth up near our hedgerows on these mornings where we're down below 32 and down in the 20s. So hedgerows, I really can't say enough about in terms of their benefits to our climate.
Pardon me. So this was just we had a friend come out, do some drone shots. So this is March of last spring. So just wanted to show you, going over one of the field, all the different diversity of, 3 beds of, this, and then 2 beds of onions and so forth and so on.
And so that diversity is in hedgerows along the edges and borders of fields. You can see fields here, hedgerows, access roads, and more fields. This hedgerow on both sides is always a lovely one because about 40 feet to your right is our field 11, and 20 feet to the left is our 140-acre conventional vineyard neighbor. And this is just a hedgerow that we actually grew all from seed and small plants in the past 10, 12 years. Again, another little video just showing, this was peak dry season. It hadn't rained in over 6 months, almost 7 months, and yet the roadways themselves are still quite green, especially with the clovers and flowering. And I can't say enough about having healthy roadways as well. Roads are often forgotten about. They're kind of the last thing to think about, but the green cover you can have in a road, not only to prevent erosion, but to help create more biological life and to create healthier soil and to create to create resources available for pollinators, such as all the clover flowers throughout the year. It just adds to the overall farm environment and really makes it much healthier. So we do have one question right now, which is about how do you get no-till practices started in the field that's set aside and has been taken over by weeds. We will certainly get to the how-to on that towards the end as we get, not towards the end, but we will get to it for sure.
Next, one of the soil management principles, keeping the soil covered at all times, ideally like this, right? With green photosynthesizing plants that are economic and like this. And one of the ways that we really do that is we really focus on doing as few direct seeded crops as possible and as much that is transplanted. And we also spend a lot of time making sure we grow very large, very healthy transplants, so that we go from one standing healthy green photosynthesizing plant to the next one, you know, in the matter of hours.
And so some of those benefits of using transplants, I'm sure many of you can think of these yourselves, but the less time the soil is bare and exposed. So obviously in the morning, we harvest out a cauliflower head. By late morning, we clear the bed of all the cauliflower plants and any weeds that might have been in there. We prep the bed if need be, and we transplant the next crop that afternoon. So it's only a few hours from one standing crop that gets harvested until the next crop goes in to continue photosynthesizing, protecting the soil, covering it, and feeding it through exudation. It's also, by using transplants, you're pretty much always getting 100% crop coverage, which is a really critical thing in vegetables when you have high value per square foot of bed space, and you've got to make sure to have a turnover all the time. You don't want to have empty space where crops failed from lack of germination. And less time in the field is more crops per year and less availability to pests. So really transplants offer a lot of benefit. And yes, she mentioned large healthy transplants. Here's some lettuces going in. We use a larger 6-packs, and in rectangular trays, 11 by 17 trays, there are 8 6-packs, so 48 cells. And we also use square trays that hold 9 of those 6-packs, 54. And they work really well. It gives a big root ball, and it means you have a good inoculated seed starting mix that already has mycorrhizal fungi in it and beneficial bacteria. And so we're constantly sending these inoculants from the nursery out into the fields, and we've been doing that for 12 years straight. It really helps create healthy soil conditions. So some more kales and summer squash going in. And then if we have to direct seed, such as carrots, radishes, turnips, peas, or beans, we love using this agricultural burlap as a way to cover the bed once the seeds are sown. And this will help keep excess sun off, excess wind off, and it'll help create a higher moisture level so that we can water fewer times and create much healthier germination conditions so that the beds stay a little warmer during the night times. And we tend to get good carrot germination in 7 or 8 days using this burlap, versus without it, we'll get carrot germination in sort of the 18 to 21 days. And then as things begin to germinate, you just lift this burlap off. And honestly, this burlap never sees the back of our barn. It just goes from bed to bed to bed as we continue to germinate various direct seeded crops throughout the year.
But overall, I would say that our direct seeded crops are less than 5% of our beds. And you can see that by looking at them. Still talking about keeping the soil covered. So, you know, not our ideal. Our ideal is keeping photosynthesizing plants in the ground, but there are times of the year when we will want to do an occultation, a tarping. Now, many farms like to use a silage tarp. We have found that we prefer using 6-foot wide landscape fabric, which is what you see here. You see some rebar on top of it to keep it down, and you also see it pins down over each bed. So this is this shot is from last year, actually, just about this season right now. And as we're just coming out of the Persephone period, right now when when we're getting to having 10 hours of daylight per day, in the dead of winter, we're not able to transplant anything. A, it's too cold and the soil is so mucky, but also there's just not enough hours of photosynthesis for the plants. So if beds are, you know, don't have anything in it, we will cover them, and then come early mid-February, we will take off those covers, we'll have a full nursery, and we will just stock those beds, and we'll be ahead of all of our competitors.
For instance, these beds here would have been cabbage or cauliflower that was harvested either for Christmas or for a January harvest, and it was still the dark of winter, so we covered the beds. And come February 1st, February 5th, we'll pull those covers off. They'll be completely weed-free, really healthy chocolate cake-like soil that's had lots of biological activity in it. And then we'll go ahead and prep the beds and transplant and continue on from there.
Lastly, incorporate animals. I think in terms of principles of soil management, this is super important. And we didn't talk about it for a couple of years because, we don't have large grazers on our farm. We do have a couple of sheep around the edges, and we do have some chickens. But I had somebody who talked to me, and they're like, why does it have to be large, livestock? You've got so many animals on the farm. And it's true. We have birds, we have reptiles, we have snakes galore, which we love. We've got frogs. We are singing Frogs Farm, right? We've got insects, so forth and so on. And all of these are really important, and just honoring, the biology and the life that we have there. This is Miguel with one of our gopher snakes. We love these guys. Our biggest pest on the farm is gophers. So these guys are our friends. And the hedgerows really help build that ecology for all of those animals, for the beneficial insects to provide a home for them. As our hedgerows have developed, our beneficial insects have increased on the farm. We have fewer and fewer pest insect problems. The birds love it, so forth and so on. Also then, manure. We do bring in manure from 3 different sources, 1 sheep, 1 horse, 1 chicken, and we do mix that in with our compost. So here, there's not much manure in this, but I put the photo in just to remind us. This is the end of summer. You can see our the end of the eggplant.
So definite great way to incorporate animals into your system. And which kind of leads you to life improves capacity of the environment to sustain life.
Which I think is one of the major underpinnings in Paul and my philosophy for farming. It's not that we want to extract, not that we want to, clear a space and just put in what we want. It's how can we work with life to create a bountiful harvest.
And it definitely makes a very chaotic system, no question about it. Yeah. But all that chaos helps balance itself out and balance each other out. And we have a lot of bounty and resiliency, especially. Resiliency is critical, so that when we had temperature that was actually up in the low 70s last week, and this week it's down into the high teens and low 20s, our plants are surviving it, despite the fact that we're getting huge, wild temperature swings.
Okay, transition. So let's talk about transitioning a bed, because this is sort of the meat and potatoes of the field work that we do out on the farm. And we're going to talk about this before creating a no-till bed, because that you do once. This we do time and time and time again. So I'm not even going to read over these because we've got these on different slides. So the first thing you're going to do is clear the bed. And take the organic matter, the green matter, and put that in the compost pile. Now, for years, we actually pulled the roots out of the ground, but we've stopped doing that, and it has been tremendously beneficial for our soil. So for a crop that's got a very hardy stem, like this one, this is a Siberian kale, this was overwintered, and despite all the flower, it actually still tasted pretty well until this time. So you can see Marty here with some loppers cutting it off just at or below the soil surface. And then hauling that to the compost pile. Then, as needed, we will add compost to the top, and occasionally we'll add fertilizers. And when we started, we were doing about a 1/2 inch to 1 inch of compost on every bed after every transition. These days, we use 1/4 of an inch to 1/2 of an inch, as little as we possibly can. So it's sort of dependent upon the chunkiness of the compost, and that only happens at about 60 to 70% of the bed transitions at this point. That said, our organic matter is pretty high. And then we will transplant our seedings right into it. I didn't talk about the fertilizers that we may use, and you may have that as a question. We don't use much for fertilizer. What we do use is an organic chicken feather meal, and that only happens in maybe half of our bed transitions. And we really will look at every bed individually in terms of what was the crop that was in here before, how was it doing, what season are we in, and what is the crop that's going in. So if it's a light feeder going to another light feeder, there is going to be no compost put on there. But if it is like the Brussels sprouts on our farm that we're just finishing up with and pulling out, they've been in there for a long time, and say we're putting in another long crop, absolutely.
And yeah, California got rid of child labor laws, so we're employing them really young these days. That's our daughter. She loves me out in the fields.
Yes.
And then, of course, you water in by hand. And then cover as needed. Here you're covering with frost blankets against cold, or with the tulle, which is a wetting decoration fabric and frost blankets both. The tulle helps keep off songbirds and deer, as well as many insects. And the frost blankets, of course, for the warmth and protection against wind, and also for creating greater humidity under there and maintaining that humidity. So the frost blankets really have a lot of benefits to creating healthier soil conditions and healthier growing conditions above the soil level for those crop plants. This is an example video that we did a couple of years ago, which shows what we just talked about in a 45-minute time lapse that only lasts about 45 seconds. And it was 3 people, and these beds are about 85 feet long, and there are 4 of them. So we'll run through this. And they're clearing the beds, using loppers on the larger broccoli plants, but using little harvest knives on the mustards to the right. And all that goes off the compost pile, makes some beautiful compost. The irrigation lines come off the bed, we put down some calcium and feather meal, 1200, the organic. Then the ½ inch of compost, so it ends up being about 2.5 wheelbarrows for those 85-foot beds each. We use a tractor to move compost around. Irrigation lines go back on, we're transplanting, and we're doing, coffee break. Very important. We all know that. You can see that we're doing the 2 lines of brassicas, probably cauliflower, and then we're intercropping with lettuces, a single line down the middle, plus alternating lettuce, cauliflower on the outside 2 lines. And once all of that gets transplanted and watered in, and boom, done. That's something that we do on the farm almost every single day. In the winter, it slows down to maybe once a week. In terms of doing, I think like last week, we just knocked out about 11 beds we transplanted into last week. This week, we're not going to do any transplanting at all because the weather's too cold. And then next week, we'll go back in and probably hit up another 10 to 15 beds next week and transplant into them.
So the point here is that the carbon biology that we're supported by the prior crops, and those crops are feeding in the soil, is going to help the next crops. And I'm actually going to ask a question right now, which is, if you notice, there are brassicas in both the prior crop, and there are also brassicas in the next sequential crop.
What about crop rotation?
What about crop rotation? So we do definitely think about crop rotation, and we think about diversity, but also with a bit of a grain of salt. And, as we're getting 3 to 8 different crops in those beds, we are having plenty of rotation. As we have built up our soil organic matter and our biology, it doesn't matter quite that much. So, we will try not to put a brassica after a brassica, but it will often happen. We grow a lot of brassicas on the farm, I have to tell you. And, you can see there's another crop, there's a lettuce in between, and the prior crop may not have been a brassica, and the one afterwards not. So in the whole system, when you look at it all, there's plenty of rotation, and there's also plenty of biology to manage it. So I'm actually going to address, Carl, you asked a question, are you trying to mimic nature in your farming practices? And we are, as much as possible, bringing in biology. You can see to the right of this little field is one of our hedgerows, bringing in Mother Nature there, but also bringing in as much diversity as we can. So yes, we are an artificial system. We are growing lots of annual crops for sale, but as much as possible, we are trying to mimic Mother Nature.
Or not mimic Mother Nature. We're trying to just make her as healthy and robust and present on the farm as possible. We still have to make an economic return on our investment. We have to turn our labor and ourselves and our inputs into cash at the end of the day to be a profitable business so we can be here year after year. And so we still have to create systems that are somewhat artificial, like these long straight beds, because it's easier with irrigation and easier with wheelbarrows. And we still have an extractive system that's pulling out nutrients constantly because we're good farmers. We're extracting lots of nutrients every day. But we're also taking care of soil in a way that is building those nutrients back in through photosynthetic capture and through better soil management and all the biology that's there, plus the hedgerows to provide more shelter for the soil biology in the plants. So really, it's not just a mimicking Mother Nature. It's even a larger idea of just creating as robust and healthy of a presence of Mother Nature as possible to make things easier.
Another question from Johnny right now. Can you tell us what plants are in your hedgerows?
There's a great website and nonprofit in San Francisco. They're called Pollinator Partnership. So if you go to pollinatorpartnership.org, they actually have a place on the website eventually that you can find that has a calculator. You can put in your zip code, and it will give you a list of all of the plants that are beneficial for pollinators native to that zip code. And we love to go in and find plants that are between 3 and 6 or 3 and 8 feet high, sort of that human scale, because we're talking about creating windbreaks and shelter belts for vegetables that are only sort of 6 inches to 2 feet tall in the soil. So you really only need to be protecting things down below 2 feet. So that 3 to 6 foot hedgerow really offers a lot of protection. And we use a lot of natives in our area here in California. We get a lot of wind as well. Our wind in the summertime, we're constantly sort of having these afternoon gusts between 20 and 45. And in the winter, our storms come through, and all week this morning, it's been sort of 10 to 20 in the mornings. And then occasional winter storm will get up to 65, 70, 75 mile an hour winds. I know that you guys probably have stronger winds more frequently. But I think that hedgerows have been a phenomenal boon to protecting not just the crops, but the soil biology benefits from those windbreaks so much.
So also I will say that, in the beginning, we planted the first hedgerow, which is actually our very first hedgerow is the one that you're looking at there on our own. But then we got some grants through our local RCD, Regional Conservation District, to put in 3,000 Sonoma County native pollinator-friendly plants. And that really bumped up our game in terms of our pollinators, in terms of our beneficial insects and so forth. We are still putting in hedgerows. Paul and the kids planted one last August.
Yep.
And we are now starting to intersperse more fruiting perennials, such as fruit trees. We do have some elderberries, medicinal elderberries that we plant. That's a great crop to have.
Blueberries, rosemary, sages.
Yeah. So
pineapple guavas for us, the pejoa guava. But you can use lots of direct economic crops in your hedgerows. But the majority of our hedgerows, for sure, are non-economic crops. And what was covering the soil between those was actually straw. And that's because those beds they were possibly tomato beds the prior year, and that had been the straw covering the shoulders of the tomato beds during the tomato season, and then it was raked off the beds for winter so that we could have full sun exposure in winter to warm the soil and keep the biology more active. And now we're into April, and the overwintered crop just came out, and the next crop is going in, and the straw is still there, suppressing weeds in the pathways.
So just sort of looking at the system as a whole, I mean, the things that for us really tie back into each other over and over is no-till, not disturbing the soil, being intensive, because when you're intensive, you are managing that soil well. You are taking out that crop just when it's ready and getting in the next one. So you have more food that you're producing, but you're also having active, young, photosynthesizing plants in the ground, and you're not having weed growth in there. And then also promoting ecology so that you're working with Mother Nature in terms of your pests.
I actually, in terms of the orientation, Lynn, that you're asking about, we have beds that are both north-south and east-west, and we have beds that are both on contour and running uphill, downhill, not on contour. And that seems like a very odd thing to be doing, to have them where the water might run down the pathways because the beds are running uphill, downhill. But on only a 1 or 2% grade, we have those beds are very short, and we have grass pathways transecting them with a grass road at the top and a grass road at the bottom. So we've actually stopped and eliminated erosion, even though we have a few beds running uphill, downhill. And so the north-south orientation, we haven't noticed a whole lot of difference. I think the one thing we focus on is with our hedgerows, we look at putting the hedgerows on the side where the prevailing winds tend to come from, but we like them on all sides of the fields. And we can put flowers and small things that are under 3 feet along the south edge, and we can put taller stuff that includes fruit trees in the hedgerows along the north edge. So the north edge of our fields in the beds tends to have fruit trees right in those bed ends. Oh, elderberries are pretty easy to manage.
So there's a question from Eric right now on how do you manage your elderberries to keep them from spreading into your own vegetable rows?
It's never been an issue. No, they're about 8 or 10 feet away, the base of the elderberries, from the middle of the first bed. And that 8 or 10 feet is significant, so there's been no issue. But we certainly do take cuttings of our elderberries and propagate those cuttings that really it turned out to be a wonderful crop economically.
Actually, one of our employees, Donald's, just took a bunch of cuttings, and he's starting his own farm, and he has a ton of wind. He's out by the coast, so he's going to be growing a lot of those.
The other part of Singing Frogs Farm that I'm sure you're aware of is that we're also obviously viable economically. And so we've looked at a lot of numbers out there, and these numbers are all numbers we got from the California Department of Food and Ag. They seem very low for sure. Some of the early ones on the California vegetable farms or organic veg farms.
It's really extensive farming versus we are very intensive.
So that's where you get the bottom half of this. And the bottom half of this is looking at like the small diversified direct market vegetable farms that are mainly organic. All the farmers that are our friends, the farmers markets, their average is $11,000 per crop acre per year in sales before, it's not profit, just the revenue. And Sonoma County vineyards, that number actually is very accurate. And it's about $11,000, getting closer to $12,000 per crop acre per year for our Sonoma County vineyards. But viability for small diversified organic veg farms is really $14,000 per acre per year and up. And therefore, most of our friends, the farmers markets that we chit chat with and hang out with, they're all doing on the order of sort of 16 to 25,000 per acre per year. So they're definitely above the average. They're doing great. They're successful.
But that's all tillage based, and I would say most of them are 15, 25 acres.
And they're really working those 70-hour weeks, and they're hurting for it, and their soil is getting worse and worse. And then with Singing Frogs Farm, we're up there around $100,000 per crop acre per year. So our system is certainly more labor intensive, no question about it. But that's where the vast majority of our revenue goes, is into our people. In fact, our net overall payment, we take about 21 of that, and the farm crew takes about 64K out of 100,000 per acre. And that's a good thing. To me, I love investing in people that are part of our community.
Something I've just been working on the last couple of weeks is our 2018 financials. And we, 2015, 16, and 17, we had pretty stable gross revenue. And then 2018, we had an employee that had moved out of the area, had worked on another farm, moved back, and she was just fantastic, and we really, really wanted her. So we're like, you got to come and work, even though it's more labor than we need. And so we said, well, maybe we can actually increase our labor, and let's see if this can increase our revenue. And we've always believed strongly in the old adage, a farmer's footstep is the best fertilizer, and small is beautiful. And we were, playing around with this idea of we really wanted to intensify and see if we could do more on the same amount of space. Well, guess what? I just ran the numbers, and the increase that we had in labor was almost exactly the same as the increase in our revenue. So we're really thrilled about that, because it shows that we can increase our productivity even just on our farm. And part of that is more quick crops, and part of it is bringing more enterprises into our space. And this is something that other people like Joel Salatin and Gabe Brown definitely talk about. But the last couple of years, we started, we have many different enterprises, with the CSA, and, then we'll have eggs and so forth. And we started a shoots production a couple of years ago. And this year, because we wanted to try bringing something in, and we have a couple of ladies who are really excited about it, who've been working with us for a couple of years. We're going to try a flower production. So
we've grown flowers for years, and we used to do a flower CSA about 10 years ago, and we're going to get back into doing a flower CSA.
Yeah, so I mean, just even saying, you can just play with that, and having people on a small amount of land and having small is really wonderful.
Oh, speaking of small.
This is a chart. There's a document at the bottom. It's noted down there by the ETC group. It's called Who Will Feed Us? The Peasant Food Web versus the Industrial Food Chain. I'm very interested in sort of what's happening internationally and so forth. And most farmers in the world do not have large space, are not industrial. And so what I love about this, I'm going to read it from the bottom up. 70% of the world's food is produced by farmers who are small shareholders. And I just think that's incredible, and goes to sort of further the small is beautiful. We don't need hundreds of acres to farm and have a good livelihood. And then if you continue to go up this, it just goes to show that it can be, really wonderful. So only 20% of the natural resources that are used by agriculture being used to produce that 70% of food. That's just ridiculous. I know a lot of people who like to look at, calories obtained for calories spent. Well, on the left over here with the industrial 1.5, part of that is because there are a lot of petrochemicals going into that sort of farming. And it's also it's just very extensive versus if you get into more hand labor intensive, you're getting out a lot more calories. You would call that a good ROI, right? I also personally love the fact that there's double the women farmers on the side. And then look at the varieties produced, 80,000 versus over 2 million. So I like thinking about it in the sense too. Sometimes in the US, we forget that, it's not all huge farms. I did Paul's surprised because I stuck this in the end.
She included some photos from our first year or two when we were tillage based, and that was what our soil looked like and our extensive organic tillage based farming practices looked like. And these are some winter squash beds, and it was a weedy nightmare. That was just sort of hard packed soil. I would do the weeding by hand or by tractor, and it didn't really get the roots out, so the crops suffered and the weeds persisted and the soil was horrendous.
Yeah.
But that's today. Now we have a
That's
very
a fast jump.
intensive system with lots of beds, lots of productivity.
And we ended up making the change, not having the soil science, not saying we want to, build up our soil carbon and go no-till and, so forth and so on. It was really just very observation based. And Paul and my background, we actually met doing Peace Corps in West Africa, where we were working in agricultural communities that didn't have access to tractors. So we didn't like what tillage was doing, didn't like how it was killing so much life in and around the soil. And so for us, it was just a process of taking out, the tractor and, creating permanent beds and using a big rototiller and then saying, we didn't like that rototiller and let's see if we can get it without it this time. Oh, wow, it actually looks great. And oh, wow, over the course of the year, we have more earthworms in that bed. Okay, well, let's just do a tilter. Oh, we don't need to use a tilter. Oh, let's use a broad fork. Oh, guess what? We don't have to use the broad fork. And so for us, it was just a step-by-step process. But for people who are jumping into it, you don't have to have that, what was it for us? It was 4 years of, learning from.
Yeah, I mean, since we didn't have any standard we were working towards, we were just fumbling along learning. It took us a while, but once we had a system of starting no-till beds and we knew how to manage them, the starting process, we ended up like in this picture, the fields in the bottom left, the two of them there, one's covered in white, one's not so much. Those two, we knew what we were doing when we went into those and made them into no-till beds. And it took all of 1 day to transition those beds from weedy fields, plow it all down, form the beds, begin doing no-till. And by the end of the first year, the soil had already doubled its organic matter and was doing phenomenally well and highly productive. And we'd had 3 to 6 crops in those beds in that very first year. So we can definitely get towards that very first question by Anonymous. But actually, I'd love to mention Steve Hess. You asked about rabbits, voles, chipmunks, etc. Oh, yes, of course. We have little cottontails and jackrabbits. Gophers are a huge problem for us. Of course, we have voles and field mice and rats and skunks and raccoons and all kinds of deer. You can see in the bottom of this picture, actually a lot of bamboo in the very lower left. That bamboo harbors a deer family. So we typically have deer that are living in the bamboo on the farm 12 months of the year, and they come out at night and eat whatever they want. And then at daytime, they go back in the bamboo and hide out. And it's been challenging for sure. But because we have created such a plethora, such a diversity of food for them to eat from, including our grassy roadways, they often find it easier just to nibble from the roadways and nibble from some of the hedgerows next to those roads. And we just don't ever have much for vegetable losses due to the deer and rabbits and everyone else. They have so much else to choose from. And I will say there's occasionally we have the deer that finds a lovely sweet tooth for a white cauliflower head, and the next morning you go out there in the fields and all of a sudden you've got 100 cauliflower heads with 1 bite in each head. And those are always those really frustrating and disappointing mornings. So hopefully we can see this slide that just came up right now.
Okay.
And this should be answering the very first question that was asked an hour ago, which is how do you actually begin a no-till field in a weedy field? Because what we mostly covered was how to maintain no-till beds, which is what we do every single day and every single week, and we will do for years and years, is the maintenance part. The establishment is the one time only. This you only do one time, and then hopefully never have to do it again unless you keep expanding into new fields.
As you see at the top, we have starting your no-till fields, sheet composting versus tillage versus occultation. We sort of see these as the three main ways of doing it, but within them, I mean, what are your resources? What is your soil? What is your ability to do that, and so forth. This photograph here, besides the fact that it's a red-tailed hawk and a beautiful rainbow, this is our new enterprise that we just we completed this winter. So this photo is from a few months ago.
Well, this is called the Enterprise, our hoop house. It's now completed. Our crew named it the Enterprise. It's huge.
Yes. This is an area that was blueberries prior. You can still see some blueberries through on the right side. Those are the bushes that were still productive. Those bushes are from the prior owners, are 25 years old. And this area, we just did an occultation because we didn't want to disturb the soil. So we cut out the blueberry bushes. We covered it in our black tarps that we use for a very long time. It was upwards of 9 months. Mm-hmm. And then we created the beds, put mulch on the pathways, and actually started to farm it intensively, as you can see, before we finished the completion of the hoop house. It is now done.
And looks a lot better now. This was dead of winter when we were still getting ready to put up the purlin and the sidewalls and skin it and that kind of stuff and put up door frames and things. So it's done.
The occultation definitely works well if you've got a little bit of time and, you know, not a huge amount of space. It can also be good, you know, if you have severe weed problems. It depends what your weeds are. And one of the things I mentioned before, or we mentioned before, that we use landscape fabric for our tarping. We like that a lot more because it's only 6 feet wide. It's easy to move. We can have a woman who's 5'4" manage it all on her own, versus what many farmers use is the silage tarps, which are huge and heavy. And we were interested in what the difference was. So last year we did get a small silage tarp. And one thing that we have found in a couple other people is that the silage tarp gets a little bit closer to a solarization. And so if you have really heavy weed pressures, and it does help a little bit with that. Mostly we don't want to do that, but we do have, for instance, one of our weeds that we deal with is bindweed. And so in an area where we had pretty bad bindweed, it definitely helped us knock it back, having the silage tarp versus the landscape tarp.
So before we get into specifics about starting a field, just things like the bed width and the wavelength. Just in our context, in our situations, we like a 32-inch bed width on the top. It's very comfortable to reach across for most of our crew. You don't want to throw out a disc in your lower back as you're reaching across a 48-inch bed or a 60-inch bed. And then the pathways, the base of the pathway where that wheelbarrow wheel is in the picture, is really only about 1.5 shovels wide. And that's as narrow of a pathway as we can create while still having room for the legs of the wheelbarrow to set down. So we use a heavy metal contractor grade wheelbarrow that happens to have a very narrow leg base. And that's critical because the narrower the leg base in the wheelbarrow, the narrower the pathways can be, which means more beds, fewer paths. And the wheelbarrow is critical simply because you have to use that to move your compost in and out of the fields. If you have very short beds, maybe you could just carry them with a shovel and therefore just do a tiny little footpath. But between the 1.5 shovels width of the base of the pathway plus the shoulders of the bed and the 32-inch width of the bed, we end up with a 4'9" wavelength from center of path to center of path. And that's just in our system. So this is one field that we put in as a no-till field, already knowing what we were doing. We already had our goal, had our picture, and this became a no-till field instantaneously, overnight. And this would have been an old fruit tree orchard from the prior owners, and they had planted a lot of pit fruits here, but it happened to be a very, very, very wet, boggy field. So most of the pit fruits died, and the ones that survived were doing pretty terribly. And what we've done is we went across the base of the field and across the top of the field and marked with oyster shell calcium chalk. We marked every 4'9", and that was our wavelength, 4'9". Then we could take this rebar with string and 2 rebar spikes at each end, and we could set them at the 4'9" marks, and then we dribble a calcium line or oyster shell calcium line down the length of the string, and we just move down the field, marking parallel 4'9" lines all the way across the field. Those marked lines became our shovel guides, and we'd go in there and with a 1.5 shovel width, scoop out the pathway and lift, pathway 1 into bed A, pathway 2 into bed B, pathway 3 into bed C, so that each bed gets the topsoil from one pathway. So of course, yes, we did do tillage before to create the blank slate to do this. And we found that within the first year of doing no-till beds, the soil is already significantly healthier than before we did the tillage to make the beds. So this system healed itself overnight, which is great. And this kind of process, you can see these beds getting composted and getting crops put into them. This field here was field 18. It has about 18 beds in it, actually. It's not why it's numbered field 18. And these beds are between between about 55 and 90 feet long. There's a couple longer ones in the back. And we marked it out in a morning, and it was shoveled and created in the afternoon. And it was a very fast, quick process for 2 people to shovel out those beds in basically half a day. And then transplanting with the fresh compost and some lines with some fruit trees.
That's our transition site.
Do we have more? We have another field here.
Yeah, this is field 11 then.
So field 11 was another situation where it was down in a low flood area, and this was January or late January, and we hadn't had any floods yet, and it was actually a heavy drought winter, and our cover crop was doing miserably. We were planning on transitioning this field into no-till beds in April or May when the cover crop was about to flower, but honestly the cover crop was failing miserably because it was just a horrible drought winter. So we ended up just plowing it under in January. And although it got a little bit wet after the plowing because of some rain, it continued to be bright blue sky and drought. So we quickly shoveled out these beds, and in a matter of a day or two, John and I just converted it over to field 11 with another 15 beds that are about 80 feet long. That's some oyster shell calcium going down.
I didn't mention that when I talked about fertilizers because we no longer use it.
So but the oyster shell calcium is a great one because we were very calcium deficient, and calcium helps the uptake of other nutrients as well. And the beds, they look awfully high here. They do start out being kind of high. That's really going to be a contextual consideration in your climate. For us, we tend to be fairly cold and wet, and so a higher bed allows more solar gain on the shoulders to warm the soil earlier in the season and keep it warm later in the season. And we also tend to be wet, so having the higher beds we like a lot. When I first started doing no-till vegetables, I was actually in Peace Corps in West Africa in the Sahara Desert, and I was doing sunken beds, where you wanted the topsoil sunken down in to be protected from the sun and the wind and the exposure of the desert. And these are sort of 5 inches high, maybe 6 inches high, but they tend to kind of just sort of slough and move and migrate 4 to 6 inches generally over their lifetime is how high they are.
I was going to say now we got a couple other questions. At this point, I mean, we got through our main presentation that we wanted to do. Just keep your questions coming in, and we may pop back and forth to other presentations where we know we have answers for other parts of those. Carly asked a question about compost, and that is something that we didn't have. Paul, if you want to start talking, I'm going to look for some compost slides.
We're obviously making as much as we possibly can. And in the beginning, when we were starting up this farm and we didn't quite know what we were doing, and we didn't even have this goal of no-till, we just knew that we couldn't use a tractor in the middle of winter when it was raining, and we wanted to get the tractor out of the soil anyway to start taking care of our soil and growing food year-round. We were definitely buying in compost, and we would buy in about 2/3 to 3/4 of our compost needs. And then we'd make the other 1/4 to 1/3 of our compost needs. And as we've grown as a farm and as we've built our organic matter levels up and we've gotten them to 8 to 11%, which we really enjoy that level of organic matter in the soil, we don't need it to be any higher. We've actually gone as high as 14 to 18%, and we didn't see any benefits. So we've actually sort of gone into maintenance mode where we're keeping our soil at 8 to 11. So we have really been able to back off compost use. And now I'd say we make a good 2/3 of the compost that we use, and we buy in only about 1/3 of the compost that we use. And we've actually done some back of the napkin calculations with a couple of soil scientists looking at how much of our organic matter increase in our soil over the past 12 years is due to compost versus soil management principles. And we found that with all the compost we've added and all the extraction of vegetable harvests and the organic matter change in the top 3 feet of soil, because we've tested every 6 inches, top 3 feet, and we found that only a good quarter or a third of our organic matter level increase can be attributed to compost. 2/3 to 3/4 of the organic matter level increase in our farm soil is attributable to all the other principles of better soil management, really taking care of the soil in all the ways that we can. So the other part of the compost is, I find that it's actually a duty of mine to bring compost back onto our farm from out in the community. I think that's a really critical thing to do. You know, our community is pretty good at recycling cardboard and glass and paper and plastic and steel and stuff like that. But if you don't recycle those, they just go to a landfill and take up space. Food scraps, however, are between 45 and 50% of what goes into landfills, and food scraps, if they don't get recycled, they don't just take up space in landfill, they also produce methane gases and other greenhouse gas emissions and they have negative externalities. They become harmful to the environment. So I find it really critical that we have municipal composting facilities in all of our townships, and that we can turn all these food scraps and biological wastes from our communities back into usable compost, which our compost that we buy in is certified for organic use, even biodynamic use, and we can add that back into our system to grow more food. So as a farmer, we're in the business of exporting nitrogen and carbon and water off our farm, and it goes out through the community, through the composter, and comes back to our farm to make more food yet again. And I think that's a really critical thing about closing the loop on carbon and nitrogen, so that you have carbon and nitrogen working for your community forever, rather than sending it out and losing it to the atmosphere or the oceans and having to somehow create more of it on your farm. It's just a very slow process that way. Whereas if you can recycle it in your community, you have a much healthier system overall.
And here, before answering that, so this little thing here, is this useful for the, yeah. I think we've gone over.
So we're just in the Q&A section again right now. So we appreciate the questions coming in. That's why we're not necessarily having the best slides, because we have to sort of jump around.
But since we're talking about compost, Carl asks any thoughts about the benefits of compost tea. Generally, we really like using compost rather than compost tea. Compost tea, if it's if the tea has been focused to for the purpose of inoculation, can be really fabulous, especially for getting started. You know, if you have low soil biology or just want to add to it. And that's definitely something we did earlier on. So that type of compost tea, thumbs up. That's very important.
But the goal is to have a system of farming that doesn't even need the compost tea. Hopefully you have a system of farming that is going to start taking care of soil in such a way that your soil becomes this robust, supercharged battery of nutrients and biology, feeding the plants and giving them their own protection against pests and diseases and viruses. So going back to the whole idea of crop rotation, we used to have, well, we've had tomatoes in the same field for 12 years. And the first 2 or 3 years, when those were tillage fields, we saw more and more disease build up, more and more pest pressure. We had more and more tomato losses and uglier fruits and lower productivity. And then we switched that field over to no-till in year 4, 5, and 6. And almost immediately as the soil improved, the tomato crop improved, and we don't have tomato viruses or diseases or pests or mildews or anything else anymore. So part of that robust success is through having healthy soil biology, which takes care of many of those problems. I gotta say, so compost tea is great in the beginning, but hopefully the goal is to get to a place where you won't need it. And then there's a quick question on the wheelbarrows. Where do we get them? Not Home Depot. Home Depot doesn't carry those. They like carrying the home gardener wheelbarrows that are all fiberglass and plastic and break so easily. So we love this heavy-duty metal wheelbarrows. Are contractor grade. We have another local hardware store chain that's called Friedman's, and they're just the blue contractor wheelbarrows. I don't know how to describe it. There's a picture of them. Click on play. But that's just the heavy-duty wheelbarrow. They're metal, and we often have fun, and we'll paint them pink and purple and green just because we can. But they're good, and they happen to have that narrow leg base nail, and so they work beautifully.
Let's stick with the compost. Kristen asks,
Sure.
regarding closing the greenhouse gas loop, what are your criteria for selecting other off-farm inputs?
Good question. So we do get compost from our municipal source that is certified for organic use. They test the nutrients coming in, and they have to test the compost throughout the process and as a final product before they can sell it. So there's a lot of regulation on compost production in California, and I assume throughout the US. That said, People always worry, are there backyard gardeners using herbicides that goes into the compost pile, that goes in the municipal compost pile? And because we do have green yard waste bins for curbside collection, just like recyclables and garbage, you can also collect green waste that goes to the municipal composting facility. And honestly, people who go out and spend a ton of money on some Roundup at Home Depot and then go spray it in their yard, they're probably spraying the gravel driveway, they're spraying the sidewalk cracks, they're spraying the weeds, and they're spraying a few things they don't want to live. But what they're cutting and removing to put in the curbside bin is really going to be branches of the fruit tree or bushes that died or
the
something
grass,
else, or the leaves they rake up. So the things they spray, the things that they put in the curbside bin tend to be different, and therefore you see very few chemicals coming in to the municipal composting process. And because of the hot composting process, everything coming out of it is certified for organic use. That said, there are the clopyralids, which do have a 3 to 4 year lifespan, even through the hot composting process. And clopyralids you'll find often sprayed on alfalfa and used for horse feed, and it can go through the horse's digestive tract and come out and then get hot composted, and it's still active and still is a broadleaf herbicide. So that's one that all composting facilities around the country are freaked out about, and they are very careful to screen for that, because if they happen to have that in their compost, they'd go out of business. They wouldn't be able to sell the compost, or it would hurt their customers who bought it. So they're taking care of their product to make sure that their product is going to be good for you. Doesn't mean all composts are good. There are definitely all kinds of quality out there. And I think that leads to one last thing I want to say on compost for now, which is never, ever use just one compost out in the fields. We never do. That's like the biggest sin on our farm. We always want to mix composts. We always want to mix two different ones, whether it's a purchased compost and our homemade compost, or whether we mix our homemade compost with a neighbor's organically fed horse manure, along with two different purchased composts, and getting the four of them blended together. But any kind of blend, any kind of mix of any two different sort of finished products is almost always significantly better than either of the products by themselves.
And we'll also do that for our seed starting mix. So we will do much larger part, a high quality compost, and then a smaller part, a potting mix that's got some inoculants and so forth. But I also wanted to acknowledge that Kristen, who asked the question about inputs, specifically asked about calcium. And we do think about all of our inputs. And so for our calcium, we chose to use oyster shell, crushed oyster shell rather than mined. And we are in California where we harvest oysters. So it was a byproduct of another process. So we definitely do think of that sort of thing.
And Roberts, you're asking about ground squirrels and direct seeding large seeds, peas, beans, and corn. Yeah, I'm sorry. That's a challenge, no question about it. We definitely lose our large seeds all the time. In fact, we just sowed our first round of cucumbers in the hoop house, in the greenhouse today, in pots, and those will get transplanted out into the hoop houses in about 3 weeks. And those cucumbers, every year we are fighting the mice and the rats who love the greenhouse because it's warm and dry, and they want to devour those seeds. And you're just going to have to figure out an innovative way that you or a neighbor has figured out to keep them away. I have to say, we use a burlap on our direct seeded beds, and that burlap has helped tremendously with keeping most predators off of those seeds, so the seeds have a chance to germinate. However, ground squirrel is going to be a little bit more smart about getting under or around that burlap to get at the big seeds. So
I don't know that our we have gophers, which are similar to a ground squirrel. I don't know that it's exactly the same thing. Probably similar problems, but they are not eating seeds. They are more eating the plants from the underside.
So Shammy and Tom, we don't use a seeder. Plenty of other farms using our model do use seeders. We like to do it all by hand, honestly. We've had a few old seeders. They were too broken to use well, and we've found that we can actually do it by hand quite efficiently and quite rapidly, though we may try out a seeder this year. I cannot give a recommendation. And the agricultural burlap, we get it at our local ag supply store. So we have a Harmony Farm Supply here, provides all things organic to everything from vineyards and big scale farms down to the backyard gardener, and they carry it. It's not in erosion burlap, which is very, very large holes, like 1/2 inch and 1 inch holes. And it's not a coffee sack burlap, which is super tight and holds in the beans and everything else. It's somewhere in between. And you can see in the pictures, it's got sort of that 1/8 or 1/4 inch holes in the burlap, and it's wonderful, but I can't, it's It's one of those shop around and you'll find it.
And then Laura, you're asking, how do we keep the burlap down? We use J pegs or J stakes.
They're wires bent into a candy cane. And we use those for holding down burlap and for holding down frost blankets and for holding down the tulle that we have covering.
Landscape fabric.
And landscape fabric, they're great. We use thousands of those. And the tulle we mentioned earlier, Tulle, that's a fabric you could buy at like a Joann's Fabrics or Michael's. And it's great for covering your plants against deer, rabbits, and songbirds, and some insects as well. So honestly, we often go to Joann's Fabrics and we find out that some other farmer was in there first and bought it all. So you now, hon, you found a website.
Toolshop.com had the cheapest.
Toolshop.com had the cheapest, and the quality actually was great. So we make sure to get as wide as we need to cover our beds, and then we just buy an entire case of like 12 or 15 bolts. So I think it was sort of like buy 12 and get 2 free kind of thing. So
just showing a picture of that burlap again.
Here's the ag burlap.
And then Florence, you've had a question up there for a little while talking about hedgerows and how do we start them and how do we maintain them and plan them. Paul, I'm going to let you take that one. I know you've talked a lot.
No, hedgerows, the 3 to 6 foot tall plants are what we're going for. So that human scale, and bigger trees are great too. I love bigger trees, no question about it. But we have hedgerows almost every 100 to 120 feet on the property. So nearly every single field has between 1 and 3 hedgerows bordering it. And we have 18 different fields on the farm. So we sort of have this constant network of hedgerows throughout all the fields in all different orientations. And we like to start them because we have a drought summer here. I don't like to set up irrigation systems for our hedgerows. To me, I'd rather the hedgerows be native or naturalized and be able to live without any irrigation or weed management. So we tend to plant them in the fall right before the rains begin, and then we water them in once by hand with a hose, and then they can overwinter with the rains, and by the next spring they've got an established root system and they're drought tolerant to go through the whole next summer without any irrigation. Or at the worst case scenario, I come along in July or August when it's peak heat and I can give them a douse of water with a garden hose to keep them thriving through summer. But we like to establish them in a way that doesn't require us to maintain them. So part of that transplanting in fall is actually to put down a lot of mulch around their base. And we'll use a lot of straw mulch. Rice straw for us is very inexpensive and very easy to work with. And we'll put down a big thick layer of rice straw around the base of our perennial hedgerows. And that rice straw will last for a good 1.5 to 2 years of weed suppression. And by that point, we either can put down a second layer of straw, or depending on the hedgerow species, the plants themselves may be large enough to shade out any weed competition below them. So I'd say that besides mulching up front for increasing soil moisture so we don't have to water them as much, as well as we plant in the fall to get them overwintered and get roots established before the following dry season the next year. The only other planning and maintenance thing that goes into them, honestly, is pruning up the undersides of the hedgerows maybe at year 3 or 4. So by the time the plants are getting fairly sizable, they tend to often still have all their young twigs down at the base underneath the plants. And that becomes a real bramble under there. And that underside bramble can be a harbor for mice, rodents, all that kind of stuff. So this is a hedgerow that hasn't yet gotten its undersides cleaned out. And we love to be able to go in there at about year 3 or 4. And here's a picture where it's cleaned out. And so you clean out all the twigs and debris and weeds and leave just the trunks and stems and branches. And what this does is it evicts your field mice. It evicts the rodents. They don't want to live there because suddenly it's more airy and open, and it becomes more inviting for your snakes. And now the snakes have space to move around in there. They can get an early morning sunlight and late afternoon sunlight so they can warm up nicely and stay warm longer in the day. But they have overhead protection from hawks, so they feel much more secure in their ability to thrive in these hedgerows. So we watch as we prune up the undersides of hedgerows for the bottom 10, 12 inches. We'll watch it change over from being maybe having some rodents to definitely having a healthy population of snakes in there. And the songbirds are always loving it. So
there's a question from Shami and Tom on, is our straw certified organic? Yes and no and yes and no and yes. So we started off by, yes, absolutely doing certified organic straw. And here in California, there's a lot of rice growing. So we have access to rice straw, which I'm guessing most people probably don't. We brought in a lot of pernicious weeds on that. So then we shifted to doing not organic straw for things like our hedgerows and our pathways and things like that, and organic when it was on top of the beds. We recently, we have a relationship with a specific farmer. His name's Greg Massa, and he does rice, and he does really organic rice. He has really fantastic products. We actually sell his rice through our CSA. So now we know our farmer and we get our rice from him. So it is certified organic now, but that took, and we communicate with him and so
he's
forth.
a phenomenal producer of organic brown rice and uses ducks for weed control. And so we've found that the straw we get from him is fairly weed free. But some of the organic straw we bought early on had those nasty pernicious weed seeds in it. So that was a real consideration up front, is whether to get the organic or conventional each time. And now we found a good source of organic straw that's fairly weed free. I think it just goes back to knowing who you get your resources from and make sure that it's a good resource, and then make a relationship.
Know your farmer.
Know your farmer.
I'm sticking on the topic of hedgerows,
just pruners. We're just pruning under there.
Asks what type of tool we use to clean up underneath the hedgerows.
It's a great winter project to do when you have crew still around, because you don't want to fire people at the end of the year. You want to have them be permanent employees year after year after year, so there's no rehiring and no retraining. So in the winter, we do a lot of projects like fixing hoop houses or building them and pruning up the hedgerows underneath. But it's really only just an afternoon job to go down and knock out a few hedgerows of pruning with your loppers and your shears, and a little bit of weeding too.
Couple
and stink
other
bugs.
Short questions. We have a question if we have stink bugs and how do we deal with them. We have a lot of different, we have every pest around that our neighbors have. And we had a lot of stink bugs on our strawberries this year. They didn't do much damage. And so really through building up the hedgerows, building up beneficial populations, as well as building up the population of predatory soil microbiology, that actually gets rid of the larval stages of a lot of insects. So yes, we have everything, but everything is in pretty decent balance.
Yeah.
So I can't give you more of a solution.
No, we used to have massive losses to pests in the first couple of years when we were tillage based.
Especially cucumber,
and
as
beetles. Our soil organic matter changed, and as the biology in the soil quadrupled, those same pests are around, but we've gone from thousands of plants a year that were lost to zero. There's just no crops lost to pest insects now. And it goes back to what she said about soil biology. So many pest insects have a life cycle stage in the soil. If they have to, as an adult, drop off your crop, burrow into the soil, lay eggs, those eggs have to hatch, the larvae has to crawl through the soil and pop out as an adult. Well, if you increase your soil biology, you're increasing all your predators down there that are going to devour the eggs or the larva or the adults trying to lay the eggs. So many of your pests are going to get taken care of simply by having better soil biology. So it sounds like a silver bullet, but I believe it is. Healthier soil biology and healthier soil organic matter can solve so many issues, from crop rotation and fertility and pest management and diseases and all the other pressures that farmers typically face. So for us, our biggest challenges are just making sure we manage our markets and our labor and our crew. And those are great challenges that we quite enjoy. And all the other things about pests, diseases, and fertility have just fallen away. They're not considerations anymore, as the soil biology has grown tremendously.
Laura has a couple of questions, and then Steve, let's get you back on.
It's Laura twice. Hi, Laura.
What kind of inoculants do you grow on your bedding plants?
Yes.
What do we use? We just use the inoculants that come along with high quality bagged potting mix. We would like to shift that over to something that we create ourselves. I was looking into creating a Johnson Sioux bioreactor for the purpose of putting some of the inoculants that we create through that into our nursery stock. But honestly, it would be a long process to get there.
But honestly, we talked about having a potting soil. Our nursery seed starting mix is about 70% screened compost and 30% potting soil that includes it's already inoculated with mycorrhizal fungi and beneficial bacteria in the potting soil. That's great, but our assumption is the soil in the fields is already immensely inoculated and immensely healthy, that what we're doing in the nursery at this point almost has no bearing. It certainly helps in the childhood stage of those seedling plants, to grow healthy, strong plants in the first 4 weeks in the nursery. But then when they go out in the fields, they're getting an even more robust soil to grow in that they just thrive in. So we don't, as of yet, make any inoculants, but we do buy a Happy Frog potting soil that already has many inoculants in it, even though potting soils are notorious for being all kinds of variable qualities from bag to bag, even in the same brand. So you have to take that with a grain of salt too. But
fantastic. Lots of really great questions.
Yeah. Wow. You guys, Elizabeth and Paul, you've made my job really easy by just chugging along, and you answered every single question so thoroughly, so well. Thank you very much. We do have just a few more minutes here if anybody's got a last burning question, because I mean, we could have Elizabeth and Paul occupy every Tuesday night for us all the way through April, and we could never get through all of their knowledge. It'd be great to have you back every night, but since we don't.
Well, if anybody wants to come out to the farm.
There we go.
We do like to have people come out for farm tours, and then we also created some workshops. We have some coming up this spring. I know it might be a ways for some of you, but we do usually have somebody from out of state every time, and we'll, go over some of these topics, give people homework, and then we actually go out in the field and do a bed transition and, look at lots of different examples that are happening around us. And we actually go into the nursery and do some seeding. So it's a lot of fun.
We have to be careful about putting out job opportunities because we can get a flood of people. So we have our own network for that one. And
there was a question, what is your favorite source for getting
workers? That's what I just said. And then our steepest learning curve for transitioning, I think it's irrelevant to all of you, because hopefully what we've seen is dozens of farms have taken our model, and in the very first year, they have been able to roll it out and be highly profitable in the first year. So there is no learning curve as long as they have this lighthouse vision of what they're trying to achieve.
Well, not
for us, we didn't have a lighthouse vision. We didn't know what we were trying to achieve, so we had to stumble along the way for sure.
Yeah.
But this is something that you can roll out this year or next year and have it be functioning successfully right away.
Yeah, so. I mean, we had Elliot Coleman and John Jevons, and just asking the farmers around us for help.
So, Steve, thank you very much.
Yeah, thank you. So I've got to be selfish here real quick and say I usually, go through these and prepare some questions to kind of generate some discussion in the chat box. Obviously, that wasn't necessary tonight, but I am curious. And again, this is a question you can probably do a whole presentation on, and maybe you do, but when you have hundreds of beds and you're turning over crops a couple times a year and doing interplanting, I'm just curious, real basic, real quickly, I mean, like, how do you keep track of those records? What do you do for managing? Because, I mean, you said 95% of everything that goes in the ground is transplanted, that you start, in your greenhouse. So if you're constantly starting seeds, transplanting, overturning beds, how do you keep track of all of that?
That you're right. That would be a nightmare to do. So I don't. That's the easy answer, but it's not the full answer. So the full answer is we love having a fully stocked nursery. Our fully stocked nursery, we've gotten to the point where we've learned about how many flats to sow every week. And so we're sowing, in dead of winter, we're sowing 30 to 40 flats a week. And right now we're sowing on the order of 100, 120 flats a week. And by February and March, we'll be sowing 140 or 150 flats a week. And we know that that's what our fields can take. So it really comes down to every week I go for a walk on the farm and I take my voice recording iPhone with me, my smartphone, and I hit the voice recorder and start walking through the fields. Well, first I walk to the nursery. And in the nursery, I look at how many flats need to go in the field this week. How many flats could go in the field this week, but need to go in next week? And how many flats will need to go in next week and could go in the week after, et cetera. And then I walk to the fields and I look and say, hey, look at that. Field 2A, I've got 4 beds of cauliflower we're going to harvest for CSA. So those 4 beds will be clear and free in a couple of days. Oh, down here in field 3, I've got a couple beds of mustards that bolted. We can pull those out. And I sort of make my list of beds that are coming free now and over the next week or two. And then I go back to the computer, hit play on the voice recording, type it all up, and then I just play the dating game. It's just simply matching beds that are coming available with nursery plants that need to go in the field. And having a fully stocked nursery like that, I always love saying it, but it's like going to the candy store. I get to walk into my own nursery. I've already paid for it all. It's all free. And you have this huge variety to choose from. And all you got to do is think about which fields and which beds are coming free and where are they? Do they have tons of exposure, or do they have great protection from afternoon sun and wind? Are they old brassica beds you don't want to put brassicas into, or did they have something else that I can easily put a brassica into? So you sort of think through all these puzzle pieces and do that dating game. And that's how it's managed. So I'd say our bed management is based on sowing seeds in the nursery for a known quantity that will fit in the fields and a known demand by our restaurants and farmers markets and CSA. So we're sowing seeds according to demand. And then it's simply what fits where. And that's a living oral history with the crew. So they know, oh yeah, that bed had this prior to the current crop, and we're taking this crop out and putting the next one in, and it'll go here. And oh, we want to make sure those beds over there are going to be free for tomatoes in 3 months. So let's make sure whatever crop we put in now is going to be coming out by the time that we want to put tomatoes in there in 3 months.
So also I want to, your question had to do also with documentation. So there is our seeding list, which is really our crop plan. So that is documented there, what was seeded. And on the other end, we have what is harvested. The documentation of what's happening in the middle, we don't keep because it's too complex.
Yep.
Gotcha. Wow.
But it also, if I could add to that, it also therefore leads to our crop planning is not a giant spreadsheet done in wintertime, planning out every square inch of the farm for the next 11 months, because that would be impossible.
Yeah.
So the crop planning is every Wednesday morning, how many seeds do I sow of what variety to maintain the constant supply for the known demand, and where do I want to push demand? Do I want to push golden beets a little heavier this year so they can go work? Do I want to push tatsoi a little heavier? Or have we seen the restaurants really want the bok choy? Let's grow some more bok choy. So we're simply sowing according to demand, which takes 5 minutes every Wednesday morning for our crop planning.
We did start out with the bigger plans.
Oh, we started out with the big spreadsheets, and we've done that before, and it was a nightmare to manage that.
Wow. Well, thank you both so much for this. I think we're past our time, so we should wrap this up now. But everybody, thank you for tuning in tonight and asking your great questions. You got Paul and Elizabeth. It looks like in Zoom here we can track you. You got them to answer 26 questions and deliver a presentation with 75 slides in 90 minutes. So that was impressive. This is one we do, like I mentioned before, this is recorded. We're going to have it on our website soon. So if anybody wants to revisit this, I'm sure you're going to learn some more by going back through this again. But Paul and Elizabeth, thank you so much for taking the time to share your knowledge with us. This was really wonderful. You guys are fantastic, and your farm is beautiful, and it was fun to learn about. So we really appreciate it.
Steve, we're thrilled that you asked us and to be a part of this. Thank you for putting this together. I mean, I think sharing with other farmers is what we all need. We still love it.
Yeah, we love learning. So thank you very much.
Yeah, well, hopefully our paths will cross again. It might not be a PFI bus trip out to California. That's a bit of a stretch, but I would love it. Maybe.
That'd be awesome.
Yeah.
All right.
We'll be in touch.
Thank you
again.